Hello everyone, my name is Prabhuti Wicaksono. I'm gonna present my homework 1, number 3, with topics of advanced pneumatics. The specific uh, homework is gonna be electro-pneumatics and PLC system with signal flow A plus, B plus, B minus, and A minus. It's gonna be a cascade system with two groups. So the components are two double-acting cylinders, two flow control valves, this one, and four limit switches, like this one, and one push button electronics, two 1 by 2-way double solenoid valve, like this one. And the components for the controller, we use Omron CP1H XA 40 GR-A. This is can be identified on the side of body of the PLC that unfortunately in the module that we got it's not in the outside module, so we have to see around the peephole like that and identify the PLC series. And for the series, we can identify that the series of the PLC is CP1H. XA means built-in analog I/O terminals, and 40 means there are 40 input output points, and D and R. D is the specific for separating the between 2 and 3. R is the relay output, so the output is classified as a relay. And then for the last one, 4, it's A. It means the power supply is alternating current, not direct current. And the signal flow, this is the initial position where A in the minimal position and LS1 is detected or pressed by the rod, and this is also the B cylinders on the minimal position, which activate the LS3. And the second step is A gonna move forward to the maximal position, LS2 detected, and then is detected, and then cylinder B is moved forward, and then the LS4 is detected, and then B minus, and then A minus, like that. So we can draw the signal flows like this one. Start, when the button start is pressed, the cylinder A move forward and LS2 is detected, and then LS2 trigger the second cylinder B move forward, and then it will press the LS4, and then LS4 trigger the second cylinder to move backwards, retracted, and it's gonna press the LS3, and then LS3 gonna trigger the first cylinder A to retract, and it was detected by limit switch 1, and then limit switch 1 gonna reset the whole system. So this is the diagram, top view of the PLC. We use this one USB port to communicate the PLC to the computer, and As we can see that for the XA there is a built-in analog I/O terminal, and we can see it here, built-in analog I/O. So the PLC is compatible with analog input output. We can control the speed of the motor using PWM, and or we can read a potentio, something like that. And this is the input, and this is the output. And this is the expansion when we need to communicate with expansion the I/O. And so if we can see, as we can see in the slides, the top one is the input terminals. It has two different two different address. Two different address. The first one is 0. This one. The first one, the first CIO 0. It means when we use connect to this one, it means the address should be 0.01. If we want to use this one, the address gonna be 0.02. But if we use this one, sorry, let's see, if we want to use this one, the address of this one is 1.00. If I want to use this one, there is a wiring to this pin. The address is going to be 1.06. The same thing happens for this one. The input for this one, the output for this one is for the output. This one output, this one input. So for the output, if we want to use this one, the address is 10001. And if we want to use this one, it means 100.03, like that one. Its address, like this one, has come to this one, and this one 01 has this COM, 02 and 03 has this COM. But usually in our module, all the COM is connected together like this. But we can separate the common. Okay, that's for the input output. And for this homework, I use this wiring diagram. So the start button is connected to input 0.00. The LS limits with 1 up to limits with 4, connected to input 0.01 up to 0.04 respectively. And the common, I use for the input I use 24 volts connected to the common. So if we have all the another pin of the component here, it needs to connect to the ground. And for the output, I use the common connected to the ground, and it's selenide connected to the positive and the other pin connected to its output pin, like that. And then this is the electro-pneumatic diagram. So this is a cascade. We can simplify the diagram using this cascade control. And by using cascade control, we can divide the diagram, the electro-pneumatic diagram, into two groups using this uh, drawing template like that one. So this is the start. This is going to be LS1, limit switch 1. This is going to be LS4, and this is the relay, the first relay, and this one is group 1 and this one is group 2. The group 1 is connected to make switch, and the group 2 connected to the break switch of the K1. So the group 1 is like this one, the template, and for the group 2 we have to use this template. It's quite simple, and by converting this to this one, we have this one for the full electro-pneumatic diagram using fluid sim. And if we want to use the ladder diagram, we can convert it to this one. Okay, I will show the electro-pneumatic using fluid sim. This is the LS1, so I will LS1. This one is LS4, and this one is LS2, and this one is LS3. Okay, as we can see, the system is going to be A plus, B plus, B minus, and A minus. A, B, B, A. Okay, let's see the simulation. Okay, yes. A, B, B, A. Okay, it happens. So to convert it to the ladder diagram, okay, I will make a new file. Save changes. No. Okay, this one device type. Okay, this one is CP1H. Setting XA. Okay. Okay, and then this one. Okay, let's see. This one is like this one. Okay, we know that we use this one is start. Start is connected to 0. Okay, start, and then this one is LS1. LS1 connected to 0.01. So, and 101, like that one. Okay. Okay, this is LS1, and this is okay LS4. This one LS4 is connected to 04. 04, LS4, it should be not. And for this CX programmer or PLC, we can use internal relay using this output. We can use this address 200 and 0.00. Okay, and this one is 200. Okay, L3 200.00. Okay, K1, and it will be less before the LS1. Okay, you can see it. Okay, and then for the rung number 1, we have the group 1, so we can contact S. Okay, oh sorry, this should be 0.00. K1 connected to the Y1 solenoid 1. It means the output is 100 and 00. Okay, that's the output, and the second output is Y3 with the address this one, Y3 with the address of this one, 100 and 100.2, and we need to make this one also. This one is LS2. LS2 is this one, 0.02. D 0.02 LS2. Okay, that's correct. And then for this one, we can use this one. Sorry, D K1 2200 and 00 out, and then first connected to Y4. Y4 is 100 and 03. Okay, this is Y3. Okay, and then we can, the output also has parallel with Y2. Y2 Y2 is this one, 100 and 01 Y2. Okay, it has also contact for this one, LS3. LS3 is this one, 0.0.03 LS3. This one LS3. This one is Y3. Okay, I'm sorry, this one is Y2. Y2. Okay, 0.0. Okay. Hmm? Sorry. This one is Y1. Y1. This one is Y3. Okay. This one is Y4. Y4. This one is Y2. Okay, that's correct. So this is the CX programmer. After that, we need to make a connection to the PLC using this one. Work online. I will show you the video. This is the video. So this is after we set the program. We connect it to that one. Okay, before that we have to make sure that the device type is the same one. The CPU type is like this one. Okay, we press the button work online. And after connected to the PLC, the initial position will, and we can download the program transfer to PLC using this button, or I can tell you this one. If it already connected to the PLC, this button will be activated or enabled. Okay. So the initial position, this is the transfer process from the PC to PLC. Ah, this one is run mode. Run mode is this one. This is the program mode. When we want to edit the program in the CX programmer, we can press this one. But if we want to run the PLC, we need to press this one. And I changed it to this one, monitor mode, because it's more flexible for me to edit or something like that. Okay, this is the simulation of the PLC program. This is the process. uh, this is the process step by step, like that. Okay, this is the CX programmer. And for the connection video, I use this one, that is the compressor. This is the computer, and then connected to the PLC. This is the module that I use to simulate the hardware. This is the connection. This is the input 0.00. It means the start button, and 0.01, it's up to 0.04. It's connected to the limit switches, and this is all connected to the output of solenoid. We can also detect the connection of input output by using these LEDs. Okay, this is the connection. This is the tube. This is the connection. We don't use this one for the. I don't use this button. I use the button on the module, and then this is the LS1, or in this module it was labeled by A0, and this I use as LS2 or A1 in this module, and this is B0 or LS3, and this is B1 or LS4. So this is the, I'm sorry, I have to, okay, this is the solenoid. This is the solenoid Y1, this is solenoid Y2, and this is the solenoid Y3, and this is the solenoid Y4. And for the pneumatic system, from the compressor, to divide the pressure, I use this manifold from this one, 6 or 8 millimeter of tube, and then connected to all things, and connected to its solenoid, and from the solenoid to the cylinders. That's all for the connection. And This is the experiment. So if I press the button, start button, A plus and B slowly move forward until P1 is reached, and after P1 was reached, B minus, and after that A minus. I will repeat again, A plus, B plus. That can be slow because of we use this throttle valve. Okay, B plus, B minus, A minus. Okay, that's all that I can explain for homework homework 1 number 3. Thank you so much for your kind attention.